All right, so it's my great pleasure to introduce Marcello Vitali-Rosati as this week's Institute lecturer. Marcello is a Canada Research Chair holder in digital textuality here at Université de Montréal. We've had the privilege of having him as a colleague since 2012. Marcello is a philosopher by training who got very enthusiastically into computers over the years, and madly so, as you may be hearing this morning. Got really very interested in all the technical aspect and strongly believe in people doing it, themselves. So there will be a lot of, engagement with that topic. He's very lively speaker also, as you will see in a minute. So it was a great way to start the week. He's published too many books and articles. So, I had like a little bio from Param, but I will sort of mention that, Éloge du Bug is his most recent book, which engages with the idea of, sort of technology and our sort of critical response to it. And so without further ado, I invite Marcello to come and give this morning's lecture.
Hi, everybody. Thank you very much, Param. Thank you, Michael, for inviting me. I would like to start asking you, how many of you are familiar with the Softmax function? I mean, how many of you know what it is, at least? Okay, not that much. Wonderful. No, it's just to understand what I can talk about. If you knew everything, I would mostly talk about theoretical stuff. But so I think I'm going to do a little math too. I'm not a mathematician. I'm very, very bad in math. But I think that now, if you want to understand something of what is going on, we humanists should go back to our math classes. So it's what I've done, and I will talk a little bit about that. If I make any mistakes and you are better than me in math, please raise your hand and say that. So the question, before starting with math, some theoretical stuff, so you can just listen and then sleep while I'm talking about math. So I want to challenge this kind of vision, according to which you have on the one hand the AI and on the other hand the human intelligence, and we are struggling to see who is the stronger one. Actually, our media are full of that these days. It's kind of, okay, it's a war. Who is going to win? I think that's really the bad way of asking the questions. There's no war. Actually, we understand nothing if we do like that, because this is based on the idea that we should have not a difference, but a hierarchy and a pyramid. The idea is you have on the top something which is very valuable, huge symbolic value. So I want to be there. And then things that are less valuable. And then you say, okay, it's the human. We want to protect the human. It's not that. We want to protect the elite. Because when you look at this pyramid, in this pyramid, there is on the top of it, normally there is something like me, a guy with a beard, a tie, white, okay? And then when you look at the bottom, there are not only non-human things. There are less human that are less human than others. So the humans who have tasks which are not really, to which you don't attribute a lot of symbolic value, they are on the bottom of the pyramid. With what? With algorithms, with machines, with animals. This is the idea. So I want to challenge this. The way of defending this human privilege sometimes is really funny. You say, why I should be on the top of the pyramid? Because I'm better. And why I'm better? And so I always cite this passage of the Turing famous paper of 1950. So it's not new. It has been at least 75 years. And he's citing a lot of arguments against the fact that the machine can think, and one of them is what he calls argument from various disabilities. And I love this kind of argument, which is these arguments take the form, I grant you that you can make machines do all the things you have mentioned. They can talk today, you can have an interaction with them, they can write a poem, but you will never be able to make one to do X. Numerous features X are suggested in this connection. I offer a selection. Be kind, resourceful, beautiful, friendly, have initiative, have a sense of humor, tell the right from your wrong, make mistakes, fall in love, enjoy strawberries and cream. This is, I love Turing for his sense of humor. And so I'm better than a machine because I can enjoy strawberries and cream. Yeah, really? And actually, the problem, as Turing says, is not that a machine cannot do that. Is why on the world should you do a machine which enjoys strawberry and cream? It's nonsense. And if we would like to do one, we could actually. It's just that we don't, because we don't need it. And I like to cite von Neumann, who said in a conference, same argument, you will never have a machine that can do X. And von Neumann answered, you insist that there is something that the machine can't do. If you will tell me precisely, this is the important word, what it is that the machine cannot do, then I can always make a machine which will do just that. Okay, you say that the machine cannot enjoy strawberries and cream, define me precisely, which means formally. Give me a formal, non-ambiguous definition of what you mean when you say enjoy strawberry and cream, when you say have regret, when you say make the difference between wrong and good, and so on. So the point here is not about making a competition between machines and human beings. The point here is giving formal, non-ambiguous, clear definitions of things. When media say that an application like ChatGPT, which is our favorite these days, is hallucinating. It's not hallucinating. You are hallucinating. Why you? It's true what I'm saying. You are hallucinating because you don't know what you are asking to the machine. You are applying the wrong model. You are asking to the model, to the large language model in the framework of this application, to do a thing which is not made for. It's just if you ask a machine, do you like strawberries and cream? But you are hallucinating. You are hallucinating, not the machine. When ChatGPT, you ask for list the books I have written, and it gives you a book that I have not written, you are hallucinating because you are thinking that you are dealing with an expert system, and you are dealing with an algorithm which throws probable tokens. So it's clear that it's not the list of my books that you are going to have. You are going to have some tokens which are probably associated with the prompt that you give. But ChatGPT is not hallucinating, you are. So the point here is, are we able to find formal and precise definitions of things? I think this is our work as humanists. So the problem is not, can a machine be intelligent? The problem is, are we able to define what we mean when we say intelligent? How we define intelligent? And actually, is there something as the intelligence? No, there are many things that we can consider as intelligence. So are we able to model different kinds of intelligence? Plural, different, not in a pyramid. I'm not more intelligent than you because I can do that, and you are less intelligent because you can do another thing. This is why ChatGPT is, we fear that much the application, the chatbot applications, because they are able to do something which normally is associated with the elite. When you have an algorithm which is able to correct orthography, you say, okay, a secretary can do that. But when the algorithm can make my lesson here, my conference, you say, okay, why should I pay this guy with the tie? I can make it do by a machine. This is the problem. It's challenging some capacity which are normally associated with the elite. So I propose to you this kind of approach, which I call the intelligent definition models. So let's try to ask questions like, okay, how can we define natural language? How can we define specific concepts? Like I'm doing a project on the concept of literary variation. What's a variation? Define feelings, what it means to fall in love. Define consciousness. And today, so what I'm going to do today is creativity. What's creativity? And the point, listen to me, the point is not to find the definition of creativity, because we cannot. Each of us will have one. And probably each of one will have many of them, according to the context and so on. It is different to be creative when you cook pie than when you do electronic poetry. It's not the same thing. And when you are doing electronic poetry like Chris, it's not the same thing as you somebody else playing around with stuff similar. So what's creativity? Can we give some interesting definitions? And on the other way around, what a particular algorithm, when you implement your non-ambiguous definition in an algorithm, this algorithm can tell you something about how it thinks. I mean, what fascinates me about LLMs is that they actually seem to grasp something about the structure of the language. They are able to speak quite well, better than me in English, for example. ChatGPT is way more fluent than me in English. Why? If you analyze the algorithm, you can probably, and you have many people working on that. I recommend to you the work of Juan-Luis Gastaldi, who works exactly on that. So, you know, all the problem about structuralism, what's the language, how meaning emerges from the language. Is it a structure inside the language, the paradigms, and so on? All the discussion about structuralism in the 20th century. And now these models are based on something like that, the distributional hypothesis and so on. So we could learn something about language theory by analyzing the behavior of the algorithm. And let's avoid this thing, there are machines and human beings, and let's ask the questions how we can define concepts. So, for creativity, now, my case studies today is creativity. I have to watch the time. So the wrong question would be, can a machine be creative? This is, in my opinion, a stupid question. And actually, if you read that close read, the text of Turing, it's exactly that, because it starts, the question is, can a machine think? And all the paper is a way to say it's an absurd question. Actually, you have to define what thinking is and what machine is. And this is what the paper is about. It's not true that Turing answers yes, what we say today. Turing answers yes, in 50 years, he gets right. No, Turing doesn't answer like that. Turing says, it's a stupid question. Just try to define what thinking is, and this is the complicated part. Defining a machine is more simple. It's simpler. But so the question, is ChatGPT creative, is stupid. The question, can ChatGPT take the place of Chris? It's a stupid question. It's just a stupid question. Why? Because what creative mean? What does creativity mean? This is the question we have to ask. What is creativity? How can we give a formal, non-ambiguous definition of creativity. And then you will see, yes, but there are many of them. Yes, many of them. But let's start with one of them. And at the end of my lecture, I will suggest you that if you don't agree with the definition that I propose, you can give another one. But pay attention, your definition should not be, no, it's another thing. Because this is the little trick that everybody is using these days. It's saying, okay, you know what the machine does? This, and this. And you know what? I can do something else. Yeah, but what it is, this something else, you don't know. If you read the article, I hate Searle. And if John Searle, the philosopher, if you read the argument of the Chinese room, it's exactly that. What can a machine do? I define what syntax is, and you know what meaning is? Something else. Yeah, this is easy. I put a frontier here, boundaries. I put something inside, and I say all the rest is not inside. Yes, sure. The boundaries are clear, but you didn't define what it's outside. So don't do that, please. Don't play this trick. Now let's concentrate ourselves on what we can put in some boundaries. And let's establish some precise boundaries. So what I propose to you is to analyze with you a way of modeling creativity, which is the way which is implemented in all these algorithms like LLMs, and especially the way of using LLMs. I will do this difference just now. And this is the concept of temperature. You have already heard about it, I guess. And please, if you don't understand something I'm saying, or if you find that it's not precise and you know better than me, please raise your hand. I studied a lot, but I'm not that good. Okay, so this is a wonderful function. At the end of the lecture, you will be able to understand exactly what it means, because it is quite simple. Who of you can understand this without explanation? Okay, not that much. Okay, so it's really easy. I can understand it. You can definitely understand it. Okay, this is the Softmax. It's crazy, because when I first saw that, I was like you. What does it mean? Then, when you understand, it's really interesting. And actually, what is going on here is some precise definition of the theoretical concepts. This is not math, is about formally defining what we are thinking. This fascinates me. So, first of all, let's say something which is very basic, I know, very simplified about what an LLM is, and let's please make the difference between LLM and applications based on LLM. It's not the same thing. An LLM, okay, it's a model, a digital model, so it's just kind of a bunch of numbers which represent the language, a language, or many languages. This is an LLM, large language model. So that means just that you have a bunch of digits which are the representation of, let's say, English. For the LLMs that we are using today, most of them are multilingual. So they represent all the possible, pay attention, which one, everyone? No. Many languages, especially the ones that have a bigger corpus. So English, for example. Okay. The applications based on it, you use this digital representation to do something. For example, you can compute the distance between two sentences. I say, I'm so happy to see Chris today. And then I say, I'm so happy to be with you today. There is a relationship between these two sentences. Actually, I can calculate the distance between these two. because I have transformed the first one in a bunch of digits, the second one in another bunch of digits, so I can calculate which is the difference. One minus the other, and then I have the difference, or something like that. Okay? The applications based on LLM, for example, a chatbot, you use this thing, then you put it in a particular environment, and you use some specific functions to make it do something. For example, for a chatbot, you ask it, okay, I give you these words, give me the most probable word that come after what I gave you. This is a specific use, and then you can add something, for example, for ChatGPT and for all the chatbot that we are using today, mainstream chatbot, you have a reinforcement learning, which prevents reinforcement learning is that after you put the LLM on the application, you add a layer of training saying with people which are reviewing the behavior and saying this is good, this is not good. Okay, this is kind of so do not make confusion between LLM and ChatGPT is not an LLM, is an LLM based application. Okay. So what does an LLM do and how it is trained? It is trained to guess the most probable following token. So you know, I make a very no, where I had a wonderful no, where it is. Okay, yes, here. Okay, yeah, very simple, very simplified example. Okay, I remember the summer nights. Let's say we have these sentences. Okay, I remember the warm summer nights. I remember the cool summer nights. I remember the laughter. I remember the joyful laughter. I remember the duck. I remember the friends from high school. I remember the friends from college. I remember the friends from work. These are sentences that you can find in a corpus. And then you try to calculate the frequency of after I remember what you can find. And here I have something like nights 3 times, laughter 2 times, 2 times, duck 1 time, friends 4 times, and so on. So I try to make it's more complicated than that. It's just to give you a general idea. Okay, and then I try to learn the probability. So I have I remember, and then so what an LLM model does is that you give it all these sentences. So with as an input I remember, and then it has to guess the output. Okay, and the output is the next token. And formally this is that. So the probability of a particular token given a particular token before. So if I give you I remember, what comes next? And this is how the model is trained. This allows, this is based on an hypothesis which is called distributional hypothesis, according to which the meaning of something is related to its relationships with the rest of the corpus. Okay, so what does X mean? In order to do that, in order to know what X means, you have to see how it appears in the corpus. For example, I like X very much. X is better cold. I like drinking X on the beach. And you understood what X is. I mean, you have an idea of the characteristics of X. It's a liquid, it's probably alcoholic, and so on. Okay? So this is the idea. This is how the LLM represents the language. So the point is, the softmax is the function that you use at the end of when you ask an LLM to guess the token. You have a bunch of numbers associated with all the tokens that the LLM has. Okay, so you have I remember, and then you have chairs, and then you have Michael, and then you have tools, and then you have freedoms, and then you have, and all this stuff have some numbers, which means that you call logics. These numbers are just the guess they are related to the frequency of these words, tokens, in the corpus. But these digits can be very, very different and can start from minus infinite to plus infinite. So you have, for example, Chris, minus 35. And then you have Roses, 154. And the idea is, okay, how can I deal with these numbers in order to transform them in a probability? In order to have what is the most probable token, okay, and the other one, how they are distributed. So it's what we call a distribution of probability, okay? And this is what the softmax is about. It's what you call an activation function, which means, okay, give me your number, and I decide which numbers will trigger an activation. So this is a good word. This is a good guess. And which other numbers won't do that or will give a very low probability. Okay? So my favorite pet is a dragon. Not that probable. A dog, more probable. A chair, not probable at all. Even less than dragon. Okay? This is what we want. Okay. So this is what the softmax is about, and just let me explain a little bit what all these things are. So you have the logarithmic function. E is the number of Euler. This mathematician, and E is 2 dot something, is an irrational 7 and so on. It's an irrational number. Just for the anecdote, Donald Knapp, the creator of TeX and Metafont, gives the versions of Metafont are numbered with the decimal of E, so 7 and so on. This is something of a geek math thing. Okay, so you have E at the power of the number in question. So you have these numbers, Z1, 2, 3, and 4, which are the logits of the different tokens. So I will give you the example just after where it is. So I come back to my example. So these are the digits. Okay, we have nights, laughter, dark, friends. This is Z1, Z2, 3, and 4. Okay, we have that. And then here we have, so Z1, Z2, Z3, and Z4. And the function, so sigma of Zi is E to the power of Zi, so 1 at the time. Okay, it's a loop. For each of this number, you apply this function. So you take this number and you use it as the power of the Euler number. And then you, as denominator, you divide it by the sum of all these numbers. Okay, so you have E to the power of Z1, Z2, Z3, Z4, the sum of them. Why you have that? Because you want that at the end, you want that the sum of every result gives 1. This is the point. So what the softmax about, we want to take a bunch of digits. No matter how they are distributed, they can start from minus infinite to plus infinite, and we want to make with them something, the sum of which gives 1, so it means a distribution of probability. Obviously, if it's 1, if you have a 0.3, it means 30%. Okay? So you have the 100%. If it's not clear, please raise your hand and ask. I try to be as clear as I can. but the example, I think you will understand a little better. So the softmax is this function, and we want the results of this function for each of the number. So we want the result, remember nights, friends, and so on. We want to know, so what's the probability of friends? What's the probability of nights? What's the probability and so on? In this case, yes, the numbers are so simple that you could just do a proportion, say on 10 or on 100, and you could do it just making the proportion. But the idea of the softmax is that you can deal with very different numbers, minus, for example, you cannot do the proportion with the minus if you have -2 in the, okay, and you want a distribution that is standardized, that is normalized. So the differences should not be too big, neither too small. So this is what you want. So we want these 4 results. And so the numerator of the fraction is the exponential function, which has base e, the Euler's number. The Euler's number, little parenthesis, is something really wonderful. You become Platonist if you discover the Euler number, because you find it all the time. So the Euler number is the number elevated to which you have the function, the logarithmic function, which is the derivative is the same as the function. This is the definition, and you find it in nature sometimes. All the time you find this number which pops out all the time. It's a really magic number, but this was just a parenthesis. So you have base e, the Euler number, and the exponent is zi, the digit to which we are applying the equation. So the denominator is the sum of all the results of the exponential function applied to the digits we want to process. So in our case, with nights, laughter, duck, and friends, we have e power 3, e power 2, e power 1, e power 4, and the sum, please believe me, but you can check with just a calculator. It's 84 dot and so on. So e is this number. And so you do e elevated to 3 divided by the sum, and you have something, and at the end, wonderful, you make the sum and you have 100%, which is wonderful. And here you have distribution of probability, which is not that surprising, okay? Because we had friends came 4 times, so we know that it's more probable. We guess that it's more probable, but you know, this is a way of standardizing the thing. And so you have this wonderful distribution of probability. And then how it works? An LLM will work in what we call a stochastic way. What it means? Let's pretend that you give to the LLM the tokens I remember. And then you say, guess what? So you can imagine that he has a bin with 100 balls on, and 23 of them are written on them nights, 10 of them laughter, 3 of them duck, and 64 of them friends. And it picks one randomly. This is the stochastic behavior, which means it's not random because it doesn't pick whatever token. No, it picks a token based on a distribution of probability. So you have actually 64% of probability to have friends. But this is the stochastic behavior of the LLM. If you run it twice, you will have different results based on this distribution, which means for the law of big numbers, if you run it at the infinite, you will have 74% of the time friends and so on. Obviously, if you run it one time, you could pick duck. It's less probable. So imagine that behavior on a huge amount of data and on a huge amount of tokens. You are not just asking to guess token t plus 1. You are asking to guess many of them, t plus 1, and then t plus 2, and then t plus 3, and so on. Each one of them is made like that. So the complex behavior represents quite the standard distribution. So this is why the model actually behaves, the behavior of the model represents an average discourse based on the corpus as a whole. Okay, but what about creativity? Okay, so let's talk, because in this case, you have a model that behaves exactly in the average. Okay? 10 minutes. Fuck. So a mathematical twist. A mathematical twist, which is we add beta there. So the idea is, what if we take a little number and we change the results in order to squeeze or to stretch the distribution of probability? This is what we call temperature, with the idea that it's a physical metaphor. The idea is the more the temperature is elevated, the more chaos you have. Okay, because things go everywhere. So beta is the reverse of temperature. So temperature is 1 on beta. The higher the temperature, the more disorganized the system is. And let's do the math. So if we increase the temperature and thus decrease beta, the difference between percentages will be reduced. So you won't have you will have results which are distributed in a more homogeneous way. So the behavior will be that less probable token will be chosen with more probability. The example. So let's put the temperature to 5, and so beta is 1 on 5. Our 4 digits will be transformed as follows. So 3 will become 0.6, and so on. And then we calculate the thing. And at the end, please believe me, these are the maths. Look at that. You remember that was 3%. Now it is 18%, which means that it is much more probable that the model will pick that, which wasn't that probable. So what's here you have a wonderful demo. My slides are online, so you can click on it and play with it if you want. No, you tell me 10 minutes. It's finished? 5 minutes? 7. It's okay. So you have that. Look at the distribution of probability here. You change beta. Okay, this is a huge beta, little temperature. You have, it will pick all the time the most probable thing. You increase temperature, and now you have quite the same thing. Okay, so, and actually another little thing is that these models are made with another little trick, mathematical trick, which is called smoothing, which avoids probability equals 0. There's no token with probability equals 0, which means that it can invent something which is probability which doesn't exist in the corpus. So completely new compared to the corpus. And even new words, because the tokens are not words, are often composed. So it can even invent words. So what is creativity according to this formal definition? So creativity is formally defined as the reciprocal of beta, which is actually a way of saying that you have a behavior that deviates from a normal probability distribution. This is a quite interesting definition of probability. The effect at the end will be that the LLM will produce discourses and sentences which are not expected because which are not expected if you expect a behavior which represents the average of the corpus. So you will have behaviors which deviates from the average of the corpus. So let's say it's a way to say Chris is creative if when he creates a poem, his poem is not, you cannot represent it as an average of all the poems he have read. It deviates from that. I like this definition because it's clear and it's non-ambiguous. Is it the good definition? This is the wrong question. This is a good definition because it is clear, it is non-ambiguous. And it tells me something. It speaks to me. Yes, I'm surprised because this behavior deviates from what I expect based on the corpus that I've learned from. So this is the wrong question. And if for you, creativity is more like, okay, so please give the formal definition of what creativity is for you. Thank you very much.